Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder how we know if babies really understand words or if they are just playing along? Well, this new study might have a clue. So, you know how babies seem to understand us even before they can talk? Scientists have a super cool way to peek into their little brains to see how they are processing words. It's called the looking while listening paradigm, or LWL for short. Imagine showing a baby two pictures, like a dog and a cat. Then you say, look at the dog, and you watch where the baby looks. If they look at the dog, it suggests they understood what you said. The thing is, researchers have been doing this LWL task for a while, but everyone does it a little differently. They choose different time windows for looking, they decide differently about what counts as a good look. And sometimes they even throw out data that looks a bit messy. Because everyone is doing it their own way, it's hard to compare results between studies. It's like trying to compare apples and oranges. But then someone paints the apples to look like oranges. This makes it tough to be really sure about what we're measuring. That's where this amazing study comes in. They took a huge treasure chest of LWL data called Peekbank, which has information from almost 4,000 kids. Their big question was, can we figure out the best ways to analyze this eye-tracking data to make sure our measurements are super reliable, meaning they consistently give the same results and valid. Meaning they truly measure what we think they measure, like word understanding. They wanted to give us clear recommendations based on this massive amount of data. So how did they do it? They looked at tons and tons of baby eye tracking data, considering all sorts of little decisions researchers make. They wanted to know things like when exactly to start looking at the baby's eyes after a word is said, and when to stop looking. They also investigated if it's better to adjust for times when babies might just look at one picture more than another, even before a word is spoken. And for those babies who are slower to look at the right picture, they examined how to best measure that reaction time. One of their first big findings is about how long you should measure. Many studies look at a short window, maybe like 300 to 1800 milliseconds after the word is spoken. But this study found that using a much longer window from about 600 to 4000 milliseconds actually made the results more reliable. Scroll figure 1. A heat map showing the average ICC across datasets for different start and end points for the accuracy window Y-score. Think about it this way. Some babies might look quickly at the right picture and then look away. Others might take a little longer to shift their gaze. By using a longer window, you capture more of that individual looking behavior, which helps make the measurement more consistent for each child. It increased reliability, which is like making the measurement more stable and dependable by about 0.2. Oh, that is a pretty good jump. Now, here is a really interesting one. Sometimes one picture might be inherently more interesting to a baby than another, like a bright red ball versus a dull gray rock. This is called a baseline preference. Some researchers tried to correct for this by comparing how much a baby looks at the target picture after the word to how much they looked at it before the word. Scroll baseline. Corrected accuracy led to worse reliability than critical window accuracy alone. But surprise, surprise! This study found that doing this baseline correction actually hurt their measurements. It made them less reliable and less valid, meaning they didn't match up as well with other measures of language ability. The simplest explanation is that when you try to subtract out this baseline-looking behavior, you're often subtracting out real information that might be related to how the child processes things. It's like trying to clean up a painting by scraping off parts that you think are random, but you end up taking away important details. Scroll recommendation 3. Measure landing reaction times with a minimum reaction time of around 400 milliseconds. Score what about reaction time or how fast a baby looks at the correct picture. They found that measuring when a baby's eyes land on the target picture rather than when they start to move away from the distractor gave more reliable results. And setting a minimum reaction time, like not counting super fast looks that might be accidental, around 400 milliseconds also boosted reliability. Scroll figure 5, heat map of different parameter options for measuring RT and how they on average affected ICC. Score this is important because reaction time is a key way we understand how quickly babies process words. By using these refined measures, we get a clearer picture of processing speed. Scroll recommendation 4, trial level and session. Level exclusions for low amounts of data are generally unnecessary. Score now. This one might surprise some researchers. It's super common to throw out data if a baby didn't look at the screen enough or if a whole session didn't have enough valid trials. But this study found that these stricter exclusions often didn't help and sometimes even hurt reliability and validity. Scroll standard practice within the field often errs on the side of excluding a large number of trials and sessions for missing data. Score basically even a little bit of messy data might still contain useful information about a child's language skills. So instead of being overly strict, it seems it's often better to just include more of the data you have, especially if you're careful about how you analyze it. They found that minimal exclusions were generally the way to go. Scroll recommendation 5. Design studies to have a minimum of 10 trials per child per condition, or as many trials as possible for individual different studies. Score moving on to design. The researchers stressed the importance of having enough data from each child. They looked at how many trials it takes to get good measurements. For accuracy, they suggest at least 10 trials per condition. For reaction times, which can be harder to get a good measure of, they suggest having as many trials as possible for studies that look at individual differences. Scroll figure 7. Simulations of measurement properties for different trial counts, created by downsampling trials for all children with different trial minimums. Score the more data points you have for a child, the more stable and reliable your measurement of their individual skills will be. It's like trying to guess someone's average height. If you only measure them once, you might catch them on a day they are slouching. If you measure them many times, you get a much better estimate of their true height. Scroll recommendation 6. Match target and distractor images based on animacy. Score, this is a really fascinating design tip. They discovered that babies have a strong preference for looking at animate objects, like animals or people, compared to inanimate objects, like toys or furniture. Scroll children have a strong preference for looking at animals and humans. Score, what this means is, if you show a baby a picture of a dog and a picture of a car, and you say dog, they'll likely look at the dog because it is an animal. But if you say car, they might still look at the dog just because it is an animal. This bias can mess with your results. If you're not careful to pair targets and distractors that are similar in terms of being living or not living, you can make it look like a baby understands a word they don't, or vice versa. So, they strongly recommend balancing for animacy when picking your pictures. Scroll how much can this matter? Score, the researchers then put it all together. They compared a researcher using a set of less than ideal, but common practices with a researcher using their recommended data-driven approach. Scroll researcher X would see substantial increases in ICC, 0.2, 0.13, 0.27, and test-retest reliability 0.21, 0.13, 0.29. Score using the recommended longer windows, no baseline correction, and fewer exclusions. They found about a 0.20 increase in reliability compared to the less optimal approach. For validity, which is about how well the measure relates to other things like vocabulary size, they saw an increase of about 0.07. This is a significant improvement, meaning the measurements become much more accurate and trustworthy. Scroll general discussion score so. What's the big picture here? This study shows us that even seemingly small choices in how we analyze data can have a big impact on how reliable and valid our findings are, especially in research with babies. By using a massive dataset like Peekbank, they gave us concrete, evidence-based recommendations. Scroll among our design-focused recommendations. The most striking result is the impact of animacy on infant-looking behavior. Score for data processing. The key takeaways are to use longer time windows for accuracy, avoid baseline correction, and be flexible with trial exclusions for experimental design. Collecting more trials per child and carefully matching images for animacy are crucial. Scroll limitations and generalizability score. Now it's important to note any limitations. The data used was mostly from English-speaking babies in the US. So while these findings are super helpful, they might not perfectly apply to studies in all languages or cultures, although the underlying principles are likely universal. Also, the studies included in Peekbank came from a specific network of researchers, so there might be even more variation out there that wasn't captured. Scroll conclusions for what this research really does is help us build a stronger foundation for understanding how language develops in infants. By making these measurement improvements, we can ask and answer more precise questions about how babies learn words and how their language skills grow. It's giving us better tools to unlock the mysteries of early language development. What I personally find so exciting about this study is how it champions a data-driven approach to science. Instead of just going with what feels right or what's always been done, they used a huge data set to prove what works best. This is the future of making our studies more robust and our understanding of the human mind more accurate. The animacy finding is particularly compelling. It shows how subtle biases in our experimental setup can lead to really different conclusions about what infants know. It makes you think about all the other subtle things that might be influencing our measurements in psychology. I think the next step for researchers using the looking while listening paradigm is to really adopt these recommendations. Imagine having a field where all LWL studies are analyzed in a consistent, optimized way. That would dramatically increase our ability to build on each other's work and make faster progress in understanding infant language. Plus, I'm really curious to see if these recommendations can be generalized to other age groups or to other types of cognitive research with eye tracking. Alright everyone, that's it for this episode of RUBIN'S Mind Lab. I hope you found this dive into infant word recognition as fascinating as I did. Let me know in the comments what you thought of these recommendations, especially the animacy one. Were you surprised? And as always, if you enjoyed this video, please hit that like button. Subscribe for more science breakdowns and hit that notification bell so you don't miss our next episode. See you next time.